Hello, so today we are going to solve this problem called closest dessert cost. And the problem says we would like to make a dessert and we are preparing to buy the ingredient. And we have an ice cream based flavors and M types of toppings to choose from. And you must follow these rules so basically we have a couple of rules, three rules here that we must follow in order to make our dessert, right? One of the first one is must be exactly one ice cream base. We must exactly use one. We can add one or more types of toppings or not add any toppings at all. And we have at most two of each types of toppings. And then we have an array for base cost, an array of toppings cost, and the target. And the goal here is to make a dessert with a total cost as close to target as possible. And we want to return the closest possible cost of the dessert to target. If there are multiple, we want to return the lower one, okay? So it seems like here the main thing is that we can add one or more types of toppings or have no toppings at all. This one is easy since we only need one. But here we can add one or more of one type of toppings. We can't add more than two for one topping, but we can have multiple toppings depending on the cost. So if we take a look at this example 1.7 and these topping costs, if we want to make target 10, we want the closest possible. We can make 10 by taking first the second base, and then topping cost of the first one, and then 0 of the second one, right? Not take anything of the second one, okay? Okay, so let's see how we can solve this problem. The first idea that came to my mind was maybe using binary search over the possible cost and seeing if I can find a function and then seeing if I can find something close to it. The closest one to target, just using binary search. But I don't think that one is good because like these rules here are complicated for binary search to find them. So I think instead I'm going to use backtracking here or just some recursion approach, right? So maybe let's say if I go through the base costs, right? And then for each base cost, I want to just check if I can get some cost there that is close to target, right? And so I will need to get result. Let's say we initialize it to just the first one, right? Because we can just take the first base and without taking any toppings at all. So we can start with that and then we can now try with maybe have a function here, a helper called possible, right? Where we give it remaining, so this is the remaining, whatever remaining of x of the cost, and I, which is the topping we will be looking at. So rem, remaining of the cost, and then I is the topping we are examining. And that would mean here I will start trying those. So I will check if possible. If for the cost, what would be what the cost would be? That's yeah. Actually, I want something and check that it's close to target. So not possible here that I'm looking for. Yeah. So the reminder maybe is maybe not that. So let's call it S. The sum so far, or maybe cost C. So C is cost so far. So far, right? And then here, we just call it cost. Let's call this just helper, right? So what this would mean is this here, well, I could just take B, right? Or I could just take B and take one topping, right? So it'll start with 0 here, right? So res is going to be just max of res. And starting with that, and here I would say if I, so nt, which would be the length of topping cost. And then here, what I would do is if I is equal to nt, then we should just turn 0. If otherwise, I can either take 1, so take choices are take 0 of topping I, or I can take 1 of topping I, or I can take 2 of topping I, right? And okay, maybe it's easier to just do like helper on B, helper on B plus. So here maybe we could do C and just go to the next one. We can maybe do C plus topping is at I. So topping cost at I. Or we could take 2 and go to the next one, right? So the rules here. But what do we want to do with these 3 here? And here I want to just start off with 0. Now, if it's equal to nt, then I want to say self, let's call this self.res. I want to say self.res is equal to the max, well, to like get best. Okay, and then I would just pass res, and I'll define best here. So we get a cost. C. Okay, so we get a cost. I want to check if it's the best so far. Okay, let's pass res as the best so far. So this so far. And then we have the new value. Now we need to check if the absolute value between the difference, we want the one with the minimal difference with target, right? And so minus target. And so if it's smaller than the C is smaller than best so far minus target, either that or we have the other case. So here then, well, self.res is going to be equal to C. Otherwise, if we are here, we want to take, if there are multiple, we want to take the lower one. So, which means if they are equal and it's lower, which means C is lower than best so far, then we want to say self.res is equal to best so far. Or actually, we can just return it that way. We don't need to access self.res here. And we have it. And then, yeah, the other calls will terminate when they need to. And then here, I could just return self.res. Yeah, backtracking recursion, it's very similar. I'm just trying the candidate, so should be similar. So here I'm doing I+1 in both cases. And nt is just the length of topping cost. So why doesn't it end up finishing here? So we start with 0, right? Okay, let's print this. Oh, wow, seems like I is never terminated. What? Okay, that's a little bit strange. Since the length is just 2, right? So it should have. Okay, that's surprising. What is the. Okay, so it should have worked. But for some reason, I reached 2 but didn't stop. Oh, I didn't return. Sorry about that. That's my bad. Why? Okay. Yeah. No, that's not possible. So let's see. Okay, so it's called with none some point for best so far, which is very strange. Should never be none. Unless, oh, okay, so there is a case where I'm returning nothing here. So in this case, just return best so far, right? Okay. Let's try the other cases. So that's that one. The other one is this and topping costs and 18. Yeah, I think this should pass. Okay, so that does pass. Cool. Yeah, I think this is good enough. Yeah, that's it for now. Thanks for watching, and see you on the next one. Bye.